Hello students, how are you? We have question 3. It says the following circuit contains a battery connected to a variable resistance. The table shows the value of potential difference and electric current, okay, through the battery. So this is the potential difference and the electric current. I have many values as you can see, okay. The question down says use the opposite graph of potential difference against electric current to find. Let's see what they want. They want me to find first electromotive force of the battery. Okay? So I pay attention to the graph here. I have potential difference in volts. Pay attention, it's in volts, so no need to change the values. Okay? And here the electric current or the current in amperes, so also no need to change the values. I guess we solved a question before on how to find the electromotive force, and we agreed that the electromotive force is going to be the point of intercept here, this point, the point of intercept with the voltage axis. Okay, so it's going to be this value, which is 1.6. So here electromotive force equals to 1.6 volts. Okay, that's it. Okay, so here there's no calculation. In B, they want the internal resistance of the battery. They want internal resistance. Okay, so we know from before that internal resistance is actually equal to the negative value of the gradient. Either you call it M or S or G. So M here is the gradient or slope. Okay, we know from math, if I want to find the slope, okay, is going to be y2 minus y1 over x2 minus x1. Okay, so I have to choose two points, the first and the second. I will choose this one here, okay, this one in here as the first point. Okay, the values here, this is 1.4, this is y1. Okay, and I go down here to the value which is going to be here. This is the x1. Let's read how much is the x1. Since this one here is all of it 1, so I count the small squares inside. I have 1, 2, 3, 4, 5, 6. So here this value is actually 0.6 ampere. Okay, this is the x1. I'll choose another point. Let's go to one which is easy to read. Okay, I'll go with this one. If you can see here, this is the second point. Okay, so notice that the y value here, I come directly to this one. It is 0.6. This is y2. Okay, and the x2 is going to be here. I go down, it is the 3. This is x2. Now I substitute. So I have m equal y2 is 0.6 minus y1 is 1.4. okay, down I have 3, which is x2, minus x1, which is 0.6. okay, I use my calculator here. Is going to be 0.6 minus 1.4 over 3 minus 0.6 is going to be minus 1 over 3. Is going to be minus 1 over 3. This is the gradient. And yes, I will have a negative value. Why negative? Because they are inversely proportional. As you can see, the line shows that they are inversely proportional. Okay, so here I come back to the internal resistance. It's minus 1/3, so it's going to be 1/3. This is the internal resistance of the battery. Of course, the unit is ohm. Okay, I hope it's clear. Okay, if you have any question, please put it in the comments. We complete the question. They say calculate the maximum power delivered to the external load. Calculate the maximum power. Okay, I'll change the color here. Okay, the maximum power, we can get it. I will have P max only in one case, when the external resistance is actually equal to the internal. At this point, or in this case, of course here not equal, this is okay. In this case, I will have a maximum power. Okay, so I can find the maximum power by, I have P max. Okay, I know the formula is resistance multiple I squared. So instead of this R, I'm going to use, it's equals to R multiple, which is the internal, I squared, whereas I is the electric current. But we have to remember something, that I know from before, I equals to electromotive force over external resistance plus internal. So in this case is going to be electromotive force over internal plus internal, because the R capital will equal the R small here. This means that the current in this case, guys, is going to be E over R plus R, it's 2R. Okay, I substitute this in here. You can leave it like this here, or if you want you can substitute it. Let's go. I can say that P max, okay, the maximum power is going to be internal resistance multiple E squared over 2R squared is going to be 4R squared, because the squared will be for the 2 and the R. Now I cut this R with the square. What do I still have? So P max is equal to E squared over 4R, which is the internal. Okay, so this is the formula of the maximum power that is delivered. Now we can substitute. We found that E was 1.6, right? 1.6 squared. Down I have 4 multiple. How much we found internal? It's actually 1/3, right? So 1/3. I use my calculator to find this value. It's going to be 1.6 squared. Down I have 4 multiple 1/3. Okay, and the answer is 1.92. I will have the answer. I will write 1.92, and the unit of power is watt. Okay, this is the maximum power delivered to the external resistance. Okay, I hope everything is clear. If you have any question, guys, please leave it in the comments. I always repeat what I'm about to say, which is please try to solve it by yourself before you check the answers. Okay, have a nice day. Bye bye.